Today's lesson covers the third method on solving a system of linear equations. And this particular method is called elimination. You're going to follow the following steps, which will make a lot more sense once we go through a couple of examples. If necessary, multiply each one or row to get the opposite coefficient for one variable. Add each row so that the opposite coefficients cancel out. Solve the remaining equation, and then as we did on Friday, you're going to substitute back into either equation to find the other variable. So the way to think about this is very simple. We have two variables, x and y usually, but they can be any two variables that we're trying to find the value of. What we want to do is eliminate one of those variables so that we now are down to one, which we can easily solve. It's the same concept as what we did on Friday, in that when we substituted one of the variables in for the other so that we were left with one equation. So let's take a walk through a few examples. Now the first one is actually already teed up for us, because if you look, the y and the negative y are opposites. So what can I simply do? I can add the columns, and I'm going to get 3x equals 6, or x is equal to 2. How do I find y? Substitute 2 in for x into either one of the equations. Choose the easier of them. And I figure out that y is 1, so that my answer is 2, 1. And if I were to substitute 2 and 1 into the other equation, I would check my answer. Now, they're obviously not going to be as straightforward as the first one, but not that much work. So now I have 4x and 3x. They're not opposites. And I have 2y and a negative 2y and a negative 1y. They're not opposites. But if I multiply one of these two equations by a particular number, I can create opposites. The easiest thing to do is to create the opposite of the negative 2y, which is a positive 2y. So I'm going to multiply the second equation by negative 2. So you'll remember this from our multiplication property of equality, that if I multiply every term by the same constant, I get the same equation. So I'm going to multiply all three terms by the negative 2. Now I've created opposites. Add my columns. I get negative 2x equals negative 14, or x is equal to 7. Now I'm going to go back in, substitute 7 in for x, and I'm going to get 9 for y, and hence I have my solution 7, 9. Please remember to write your solution as a coordinate, meaning put parentheses around it. Right? It is not to be written in set notation form, because the answers here are a coordinate, an x, y value. Okay. Now, if you look at the following example, it's a little trickier because 4 and negative 3 and negative 4 and 5, I can't multiply one of those equations by a number to create an opposite. But I can multiply both equations by a number to create an opposite. So I'm going to multiply the top one by 5, the bottom one by 4, so that I get 20x minus 20y equals negative 40. And then I get negative 12x plus 20y equals 0. Now I've created my opposites. So this becomes a bit of a numbers game, in that you have to figure out what's the easiest way to create opposites. Sometimes you'll see it very easily, sometimes you won't. As long as you create an opposite and do your multiplication properly, you'll be fine. I get 8x is negative 40, x is negative 5. Substitute in negative 5 for x. And you'll get y is negative 3. So my solution, -5, -3. The next one, you can go one of two ways here. I'm going to multiply the top one by -2. You could have multiplied the bottom one by -2. Doesn't matter. So I get -12x minus 2y equals -12. 3x plus 2y equals 9. So now I'm left with -9x equals -3, or x is 1/3. I put 1/3 in for x. And I get y is 4. And so my answer is 1/3, 4. And then finally, my last example, I'm going to multiply neither one because I already have opposites. I just add the columns. I get 8x equals 8. X is 1. Substitute in. And I get my answer of 1, 3. So the last of the three methods is called elimination. And if you look at it and say to yourself, when do I use whatever method? Well, if both equations are set up in what we call standard form, where it's something x plus something y equals a constant, elimination usually lends itself to being used because you don't have to convert into y equals form. The other thing is you'll see elimination to be useful when you get answers that are fractions, like in the one over here, because graphing and coming up with a fractional answer is usually not very easy to deal with. So the third method that we did today, elimination.